Hello everyone, this is video 12.8. We're going to be looking at contrasting and relating the perimeter and areas of shapes. So obviously, if we're going to be talking about the perimeter of shapes and the area of shapes, and by shapes really we're talking about polygons, and for the most part we're talking about quadrilaterals or quadrilaterals being combined. If we're going to be talking about perimeter and area, then obviously we need to make sure that we understand something about perimeter and area. So if you're a little shaky on those two topics, make sure you go back and review perimeter and area before you start. All right, let's get going then. So think for a second about how we find the perimeter of a polygon and how we find the area of a polygon. And you can see there's a lot of similarities. I mean, if we just start with rectangles, this sort of basic quadrilateral, then we know that the area is the base times the height, and then the perimeter is going to be the base plus the height plus the base plus the height. Uh, you could simplify that down to 2b plus 2h, twice the base plus twice the height. But in its most basic form, if we just sort of trace around the rectangle, we're going to add the base, the height, the base, the height. So in both cases, we're using the base and the height. And so there's some similarities there. We have to know the sides, the lengths of the sides, in order to find the area or the perimeter. And yet, in one case, we're using multiplication, and in the other case, we're using addition. In one case, we're using the base and the height exactly once. In the other case, we're using the base twice and the height twice. In one case, we're getting a linear measure. The perimeter, we get the linear unit, so our answer would be in inches or centimeters or miles. In the other case, in the case of area, we have a square unit. So square inches or cubic centimeters, or I'm sorry, square centimeters. We're not talking about volume. So we have squared units. So centimeters squared, inches squared, square miles, whatever. So there's a lot of similarities between the two. The reason why we're talking about this is because it's easy for us to lose sense of how confusing these two things might be, how similar they are, and yet how sort of dissimilar they are. So for students learning this for the first time, to take some time to focus on sort of example and counterexample, seeing how this applies but how this doesn't apply, seeing how this is similar and yet dissimilar. If we don't address the dissimilarities, then we run the risk of students sort of like merging these two ideas in their minds and not understanding where the line is. And we want to make sure that we keep things as clear as possible. As students start to blur the lines between these two things, we want to clarify that and make that distinction. So let's look at an example. So the example that I want to look at, this one here, deals with this question about perimeter and area, and does the same perimeter mean the same area? And so by answering this question, we'll do some calculations with area and perimeter. So I found this picture online, and we've got three different rectangles here. You can see rectangle 1, rectangle 2, rectangle 3. And so our side lengths for this one are 1 and 5. And so we can see, and we'll put the perimeter here and then the area here. So the perimeter here would be 1 plus 5 plus 1 plus 5. So we have a perimeter of 12 units, whatever that is. And then the area is going to be 1 times 5, which gives me 5 units squared. So you see what we're talking about in the previous slide. For the perimeter, we need all four sides, although for a rectangle, we know that each length is equal in length of the opposite side. For the area, we just need the two perpendicular sides here, the 1 and the 5, and multiply them. So we can see how the sides are used similarly and yet dissimilarly. We can see how we get a solution that's calculated similarly and yet dissimilarly. We see how we have units that are both similar and dissimilar. They're similar in that they're both units. They're dissimilar in that they have different dimension. But the point of this question is, does the same perimeter have the same area? And so if we look at rectangle 2, we see that it has dimensions of 2 by 4. And so if I add these together, 2 plus 4 is 6, times 2 is 12. And so my perimeter here is 12 units. And so we have the same perimeter. And yet if I take the area, I get 8 units squared. And you can probably see where this is going. This over here, rectangle 3, which is a square, but remember every square is a rectangle, so this description still applies. I get 12 units here, so 3 plus 3 plus 3 plus 3. It gives me 12 units. Again, perimeter, linear measure. And now my area is going to be 3 times 3, which is 9 units squared. So the answer to this question, does the perimeter mean the same area? Obviously, no. We've got 3 rectangles here that were chosen because they all have a perimeter of 12 units, but the areas are all different. We got 5, 8, and 9 square units as the area for each of these 3 rectangles. It's not an obvious question, or at least the answer to the question isn't obvious, I should say. If we have 3 shapes with the same perimeter, a lot of students might assume that they have the same area, and the fact is that's not the case. The other side of this question we'll look at next. So now the question is, does the same area imply the same perimeter? And here we can see we've got a 6 by 4 rectangle here, and then we've got an 8 by 3 rectangle here. And so we can see that the area for both of these is 24. So the area is 6 times 4, which is 24, and the area is also 8 times 3, which is 24 units squared. So we've got the same area for both of these. But does that mean that the perimeter is the same? So if I add up these perimeters, then I get 6 plus 4 plus 6 plus 4, and so that equals 20 units. And then over here, if I add up my perimeter, I've got 8 plus 3 plus 8 plus 3. That's 2 times 11, so that's 22 units. So we can see that having the same area does not necessarily imply that the perimeter is going to be the same either. Now, I want to clarify something real quick. Earlier on in this chapter, we talked about the idea of proof, and we talked about the idea that in order to prove something, we have to prove it in the general case. When we were talking about the area of a circle, we talked a little bit about the idea of proof. And so how come we can't prove something by example, but here I'm using example to show something is the case? Well, the reason is we can disprove a statement by showing a counterexample. Do I think this is always the case? Well, no, it's not always the case, because here I found 2 rectangles that show that it's not always the case. So you can disprove a statement by giving one example, and that is sufficient to show this does not always work, because I've shown you a case where it doesn't work. To show that something does work requires a proof that, again, we talked about before, proves the general case. So that can be a little confusing sometimes for students working with proof for the first time, that sometimes we have to prove all the cases and sometimes we have to show one case. The difference is whether or not we're proving something to be true or disproving something, showing that something is false. So for your checkpoint problem, I want you to take a piece of paper and find as many rectangles as you can that have a perimeter of 36 centimeters. And again, we're using integer side lengths here, so you don't need to worry about fractions or decimals or anything. Just use whole numbers. And so we want rectangles with a perimeter of 36 square centimeters. Now, find the area of those rectangles. Which of those rectangles has the largest area? And then can you predict which of those rectangles would have the smallest area? So there is a relationship between that perimeter and area of those rectangles, which sort of builds on what we've talked about in this video. And it's actually a pretty important relationship that we'll talk about in class. So if you have any questions about this problem or anything else from this video, as always, bring those questions to class and we'll get them answered. All right, thanks.